Hey, we have here today an interesting integral from the UNSW Integration Bee 2022. This was knockout round 3, problem 3. We have the integral from 0 to infinity of dx over 1 plus x to the 2022 times 1 plus x squared. Okay, right away on this one I had a substitution in mind, and it's got to do with the fact that we see an x squared here, and then also we kind of have an even power over here. It's making me think we could do the substitution something like u equals 1 over x. This tends to work really nice, especially with these bounds like this, because it'll flip our bounds around. So from here we can get a value for x, of course. We can find that x is going to be 1 over u, and I'll just take my derivative. And for the derivative of 1 over u, we're going to have minus 1 over u squared. And I think this is probably why this works so well, is because we have the x squared here, and we're going to multiply in a square term. So let's just go ahead and make this substitution. So when I plug infinity in for x here, this is going to 0. When I plug 0 in, it's going to infinity. So we just swapped our bounds around. Then for our dx, let's just write the 1 in the numerator here, and we'll have our du. I'll actually put the minus on the du and the u squared here so that we can multiply that into the denominator here. And let's just write this all out. So we're gonna have, instead of x here, we're gonna have 1 over u to the 2022. And this is gonna become 1 plus 1 over u squared. And what I'll do is I'll take this minus sign, bring it out front, and use to swap the bounds so we can put it back to the way it was here. And then I'm just going to multiply this u squared in here. And when I multiply this in here, it's actually just going to become 1 plus u squared, which is kind of like what we have right there. And now before I rewrite this, I also want to fix this one. And what I can do is I can multiply in a u to the 2022, but I'll do it in the numerator and denominator, so I'm not changing it. So let's distribute that in and see what we have. We'll multiply it out, or whatever you call it. So we'll have our u to the 2022 here in the numerator. Then here, when we multiply this in, I'm going to swap the order. So when we multiply u 2022 times a 1 over u 2022, that's going to give me a 1. And then this is just going to be times 1 here. And then here we're just going to have our 1 plus u squared. And the nice thing you may notice is we really have the same denominator here as we have in our original. We also have the same bounds, which is going to help. Now we just have a different variable, right? But because this is a definite integral, I can do a variable change because it's not going to change the area under the curve. So let's change the variable back to x, and then we'll add these two integrals here together. Okay, I actually kind of combined two steps right there. So what I did was here we changed the variable back to x. And then from here, we took this integral and added it to this integral. They're the same, so we end up with two copies of the integral 2I. And notice we have a 1 in the numerator here. We have an x to the 2022 here. So our numerator became 1 plus x to the 2022. But that is perfect because that's going to give me cancellation here. But now we're integrating a very well-known integral. We've got here 1 over 1 plus x squared, and that's actually going to be just arctan. So we'll integrate that to arctan, and we just need to evaluate that from 0 to infinity. Well, arctan at 0 is just 0, so we just need to evaluate arctan at infinity. Well, arctan evaluate going to infinity is just going to be pi over 2. Now all we need to do to finish this off, we notice this is two copies of the integral, so I'm just going to divide this by 2, divide this by 2, this cancels here. And so for our final solution, we're just going to have pi over 4. That's it. Really nice problem today, so we'll stop it there. Thanks everyone for watching. Please like and subscribe. Have a great day.